Hi, my name is Leo Lam, and this is my project 3 for ME 3210, which are my favorite topics that we've learned so far. So here's the agenda. Rolling. So rolling reduces the thickness or alters the cross-section of a long workpiece. This is done with two large cylindrical tools which apply compressive forces throughout the set of rolls. Now, this was first developed in the late 1500s, and now 90% of produced metals from metalworking operations are result from rolling. Rolling is used to produce large sheets that are used in automobile bodies, aircraft bodies, office furniture, and more. It's also used to create threads on screws, bolts, and any other threaded part. Two rotating die form the threads on the round parts via a cold forming process. It also creates spur gears and helical gears. One of the reasons why rolling is important is because of its ability to make threads. Almost all externally threaded fasteners utilize rolling now, and that's because, as you can see from the diagram on the right, the grains on a rolled thread is much less susceptible to shear compared to a machine thread. I always thought threads were machined because of how they're designed in CAD using a helical sweep cut, so I really like rolling because it subverted my expectation and created a stronger thread. So some capabilities and limitations. So some capabilities include the fact that they're easily able to reduce the thickness of a plate to a desired measurement. They're able to create strong threads and gears, which is super important. And you can also use hot or cold rolling depending on the material to create various desired product attributes. Some limitations include the fact that rolling can cause surface defects. There are structural defects that can decrease the integrity of the material or the product as well. And also rolling can cause wavy edges that cause thinner exteriors and edges compared to the center of the workpiece. End milling. So for end milling, a cutter rotates on a perpendicular axis, or sometimes is tilted, to the workpiece. The cutter moves vertically to achieve its desired depth. Now, end milling usually cuts metal, and it can be either manual or programmed. End milling is used for metalworking and woodworking. It's used on electronics such as PCBs. In the aerospace industry, it helps create parts for the turbine. It creates molds for the tool and die industry. And it creates orthopedic implants and other things for the medical industry. So the reason why end milling is important is because it's precise and it can accurately cut materials. It's very versatile in creating complex geometries. Specifically, it's very good at creating molds. And molds are used in all other types of processes such as injection molding. End milling is very valuable in prototyping as well. I like end milling because it allowed us to pocket a piece for a robot that we had in order to reach the weight limitation. So some capabilities of end milling include that it's able to create precise and accurate parts. These parts are used in other manufacturing processes such as mold. So things like injection molding relies on the ability to end mill the mold. You're able to remove unwanted material, and you're also able to improve surface finish of other more inaccurate cutting techniques. Some limitations include that the fact that if it's a manual mill, you require skilled labor. Otherwise, if it's programmable, you have to program it to cut out exactly what you want. It also has a low to medium production rate, so it's quite slow. Lathe. So a lathe is a high-speed machine that rotates the workpiece around a stationary blade, which allows the blade to slowly shape the workpiece, as you can see from the animation on the right. The blade moves in order to cut deeper or further down the workpiece, depending on what you really need. It's considered to be one of the oldest machine tools. Lathing has many applications in woodworking, metalworking, and industries such as automotive, aerospace, and medical. For example, it can be used to create baseball bats, it can be used to create wheel hubs and axles. In airplanes, it can create turbine blades, and in the medical industry, it can help create some surgical instruments. So, importance, it's one of the oldest machine tools, and its effectiveness led to many other machine tools to be developed. Also, as I mentioned, lathing has so many applications in the world. And that's because it's very versatile. It allows it to do the work of many other machines. I love how versatile the lathe is and how it inspired a generation of machining. Capabilities include that it can shape, drill, sand, turn, cut, deform, and more. It's just a very versatile instrument. Some limitations, however, is that it's a low to medium production rate, and it also relies on symmetry since the workpiece is spinning about its axis of symmetry. Swagging. Swagging is when a rod or tube-shaped workpiece is reduced in diameter by reciprocating radial motion of 2 or 4 die. So there's a set of rollers that contain the die movement, and there's a hammer that periodically closes the die when the roller pushes down on it. It's often operated at room temperature, and it's limited to part diameters of about 50 millimeters. Some applications include circuit boards. It can be an alternative to soldering, and it's used in aeronautical and automotive parts. It's also commonly used in firearms to create the barrel of the gun. The importance of swagging is the fact that it can improve mechanical properties of the workpiece. It's also chipless. It doesn't really cut that much off. It more deforms the workpiece. So that way it produces products with minimal material waste. Therefore, it's highly economical as well. Swagging also gives you high control of wall thickness throughout the process. I like swagging because of its smart design of utilizing the rollers in order to periodically activate the hammers. Capabilities include how it can reduce the diameter with very good dimensional accuracy. It's able to size, reduce, shape, taper, bond, or form metal parts. Some limitations, however, is that it requires a skilled operator, it needs a lot of space, and it can be quite expensive as well. Incremental forming. Incremental forming is a class of processes that result in the material being formed in small increments. For example, incremental stretch expanding uses a steel rod to deform blanks into axisymmetric parts, as you can see from the picture on the right. Incremental forming can use CNC to follow various contours of different depths across a workpiece surface if it's programmed properly. And incremental forming is usually performed on aluminum alloys with very high formability. Some applications include some house appliances. It's used in the automotive and aerospace industry, as well as the medical industry. But one of its most useful applications is in rapid prototyping. So it's able to create complex 3D shapes without a die. That means there's less lead time and it's more cost efficient, which is one of the reasons why it's very good for prototyping. I like it because I think it's a very unique manufacturing process that can create really unique things with metals that you would normally not expect metals to be able to make, such as the picture on the right. Capabilities include that it has very high flexibility, has low tooling costs, and it's able to rapidly prototype sheet metal parts. Limitations, however, include low production rates and the fact that only a certain amount of materials can be used, specifically those aluminum alloys. Not all materials can use incremental forming. So here are my resources for this project. As a disclaimer, this video was made for educational purposes.